Hello guys. Suppose we're given the following function and we need to find its Maclaurin expansion. First of all, notice that we have a cosine function here, and we know its expansion. Cosine of x equals 1 minus 1 over 2 factorial times x squared plus 1 over 4 factorial times x raised to the 4th power, and so on. Or in a compact sigma notation, this is a sum for n from 0 to infinity of negative 1 raised to the power of n over the factorial of 2n times x raised to the power of 2n. And this is for real x. As we can see, in our case we have the cosine of 4x, so we need to substitute 4x instead of x in this formula. Let's do this. Cosine of 4x equals 1 minus 1 over 2 factorial times 4 squared times x squared plus 1 over 4 factorial times 4 raised to the 4th power times x raised to the 4th power, and so on. Or it's a sum for n from 0 to infinity of negative 1 raised to the power of n over the factorial of 2n times 4 raised to the power of 2n times x raised to the power of 2n, also for real x. Finally, to find the Maclaurin expansion of our function, we need to multiply both sides of this equation by x. X times cosine of 4x equals x times this expression, 1 minus 1 over 2 factorial times 4 squared times x squared plus 1 over 4 factorial times 4 raised to the 4th power times x raised to the 4th power, and so on. And this gives us x minus 1 over 2 factorial times 4 squared times x cubed plus 1 over 4 factorial times 4 raised to the 4th power times x raised to the 5th power, and so on. Or in the compact sigma notation, it's a sum for n from 0 to infinity of negative 1 raised to the power of n over the factorial of 2n times 4 raised to the power of 2n times x raised to the power of 2n plus 1. Once again, this is for real x. So here's the Maclaurin expansion for the given function.